we talk about the molecular geometry. In the first section, we explain the valence shell electron pair repulsion theory. And we said that there is three important things you have to understand in the valence electron pair repulsions. First, you have to determine the number of atoms within the molecules. If it's two atoms molecules, so it's linear. 3 atoms molecules is no. It's linear if it's have no lone pair in the central atom. It's bent if it's have lone pair in the central atom. Then we talk about if it's 4 atoms molecule, trigonal planar or trigonal pi pyramids according to the lone pair. Then 5 atoms molecules, or we said that tetrahedral, 6 atom, octahedral, 7. More than that, trigonal pi pyramids, 2 pyramids. That we explain here. Yeah. Yeah. And I make a summary for you, and I told you that if you draw the compound here, barium fluoride, is there any lone pair upon the central atom here? No, so the only shape here could be linear. But if it's like here, the SN, do you see? There is 2 lone pairs, so it's a bend. Then we talk about the 3 atom with no lone pair like PH3 or PF3, boron fluoride. This is trigonal planar and have equal angles, 120. And here the tetrahedrals, 4 atoms molecules like CH4, okay? 5 atoms molecules, like in the central atoms you have 4 arms here, and there is no lone pair, we name this tetrahedral. And then we talk about the trigonal pyramidal. If it's 4 atoms molecules with a lone pair in the central atom like ammonia, upon the nitrogen there is a lone pair, and we know that the orbital of the lone pair occupy much space more than the shared orbitals. And its force make this compound have an angle less than what? 100? Less than? 120. Less than 120, 109. Here, for the bent one, if we have 2 lone pair here, so the 2 things here, I said that 4 things. 2 shared, 2 lone pair, and this will bend the molecules down and make the angle between the water molecules approximately 105 or 104.5 between the covalent bond here. And we have here for the 6 atom molecules, if it's have the 5 bond, this is an exceeded of the octet rule, because the phosphorus and sulfur, the phosphorus surrounded by how many electrons? How many electrons surrounded by the phosphorus? 10, not 8. So exceeded the octet rule. Also for the sulfur, 12 electrons. There is no more than 12 electrons, okay? And this shape is called octahedral. Here is trigonal bipyramidal. Then, now, we will talk about hybridization. The hybridizations, guys, along with the valence shell electron pair repulsions, will explain the molecular geometry. Because in some molecules, when we try to understand, we will see that it's capable only to form 2 bonds, but actually it's forming 4 bonds. From where this bond comes? We will understand. We have 3 types of hybridization here in this sections. We will explain it, try to know how this happened, okay, to understand the hybridization in a simple term, of course, okay. For this purpose, we use the model of hybridization. So, a step further must be taken to explain how the orbital of an atom is rearranged when an atoms form a covalent bond. So we need, with this as explanation, along with the valence shell electron pair repulsion, to explain the molecular geometry of the compound. Okay? So for this purpose, we use the model of hybridizations, which is a mixing of 2 or more atoms orbitals of similar energies at the same atoms to produce new hybrid atoms orbitals of equal energy. If I told you, what does actually hybrid mean? Hybrid, like hybrid cars.
Electric? Half and half.
Mix of something, right? Like the hybrid car, electrical and with you have an engines with the benzene, right? Or the fuel, right? So it is the same thing, guys. Within the atoms, we have different type of orbitals. We studied this in the previous semester, 4 type of orbital, right? SPDF, right? Each one have a specific shape, right? The hybridizations that happens between orbital gives us a new orbitals with actually 2 characteristics of these between the two orbitals that make the hybridizations between them. How would that happen? Take the simple example of methane, CH4. Before we go through that, let's explain the methane molecules first. Where we start with which type of molecule? CH4. Do you remember the lowest structure for it?
Yes.
What?
As carbon in the middle and
Tetrahedral structure, right? If we draw it with the tetrahedral, do you remember how we draw it? The bolded one towards you, the dashed one in the board, and this is one here, and this is one here, okay? This is how look like, tetrahedral structure. How many bonds here, guys? How many bond? How many covalent bond? 4 covalent bond, right? Let's first, this is not supposed to happen. If we draw the carbon, what is the name of molecule? Methane. It's a gas, guys, okay? CH4. If we make the electronic configuration for the carbon that have 6 atomic number, what is the first orbital, guys? 1s. How many electrons? 2. 2s. How many electrons? Then 2b. How many electrons? 6. 2 electrons. Total 6 electrons. Okay? When we explain the covalent bond at the beginning of this chapter, how many electrons, single electron here? 2 single electron, right? This is mean the carbon atoms capable to form how many bonds? 2 bonds. From where this 4 bond comes? This is the question. This is how the scientists actually discover the hybridizations. They started to know if we have here only 2 single bonds capable to form 2 bonds, from where this 4 bonds comes. So first concept of hybridizations, guys, it's happen between the orbital of the same atom. Okay? Between the orbitals of the same atom. For example here, for the methane we discover something. The energy of these orbitals, the atoms actually make some update for its orbitals by make hybridizations. It means that mixing between characteristics of an s orbital and p orbital. The valence orbital here, guys, is what? sp. This is the valence orbital. Have 4 electrons in the outer energy level, right? So this is the valence electron. So what actually happened? The 2s orbital here. How many orbital in the b? 3. So bx, by, bz, right? So we make hybridizations between s and 3b to create 4 orbital from its type sp3. This is a type of hybridization. Hybrid orbitals. So what is the type here? sp3. Why we name it sp3? Because we make hybrid between 1s orbital and how many p orbital? 3p orbital. Okay? Let's remember the shape of the orbitals, guys. What is the shape of s orbital? The shape of s orbital in the yxd. Perfect answer. Spherical shape, right? Yes. And the p orbital, guys. What is the shape of it? Do you remember? For example, here is y, dumbbell shaped or loop, right? Dumbbell shape or looped, guys. This is the x, this is the z. This is the 3 orbital of p, right? Hybridizations, we will make an upgrade for the orbitals, okay? We will mix this s orbital with the 3p orbital to form how many orbitals? 4 orbitals, capable to make how many bonds? 4 bonds. If we get back here to the carbon, so how that happened? First, the hybridized orbitals are equal energy. But here, does the s and p equal in energy? Which is one have the higher energy? P orbital have higher than the s. So first, actually there is something happened within the atom, make the s orbital, this electron here, jump becomes here, Okay, after the atoms excited. When the atoms become excited, what happened to the electrons, guys? Jump from the lower to the higher energy levels. And this is what happened here to the higher orbitals here. To form SB3, sp3. This is in total how many orbitals, guys?
4.
4 orbitals. Capable to form how many bonds? 4 bonds. How that happen? The orbitals, if we have the characteristics, guys, of this is hybridized orbital, we name it sp3, have the characteristics of an s orbital with 25% and 75% of p orbitals characteristics. Impose, yes.
How you got for SP3?
For sp3. The type of hybridization. From where? How many s orbital we take? 1 s. And how many p orbital? 3. So we name it sp3.
From where you get 3? Because
2b. How many orbital in the 2b, Anas? How many p orbital? bx, by, bz, right? bx, by, bz, right? So hybridization happens between l s and b to form 4 orbital, 4 hybrid orbital from a type sp3. Capable to form how many bonds, guys? 4 bonds. But as I said, these orbitals, guys, are equal in what? So if we draw the carbon after being hybridized, this is the 1s2, and we have 4 orbitals of a type what? sp3. This orbitals, I said that, is combination of characteristics of ls and p orbital. It's lower in energy than lb and higher than ls. It's in between. To form 4 equalized orbital, each one have many electrons? 1 electron. Capable to form how many bonds? So do you understand the difference between here and here? And how the 4 hybridized orbitals capable to form 4 bonds? And this is meaning hybridization. What type of hybridized? sp3. Do we have another type? Right. We have 3 types here. This is what we found in the book. sp, sp3, sp2, and sp3. With your knowledge, if you understand, what is the meaning of sp? Hybrid between what? 1s
and 1b.
and 1b to form how many orbitals? 2 orbital. sp2 means what? 1s with 2b to form in total 3 orbitals are equal in energy. sp3 means 1s orbital with 3p orbitals to form 4 hybrid orbitals from a type sp3 equal in energy.
So it will form 4 bonds.
Exactly. And this has affected the geometry to give us the methane with what type of geometry, guys? What type? Tetrahedral structures, right? With an angle less than what? Less than 1905. Let's get back to see the shape of it. But do you understand the characteristics, guys? I said that if it type, let's first revise here. So, take the symbol. Okay, experiment has determined that the methane molecule is tetrahedral. How does carbon form 4 equivalent tetrahedrali arranged covalent bond? This is what the question that we start with, the scientist. Recall that s and p orbitals have different shape. To achieve 4 equivalent bonds, carbons 2s and the 2p orbitals hybridize to form 4 new identical orbitals called the sp3 orbitals. So hybridization is between s orbital and how many p orbital? 3. To form how many hybridized orbital? 4 hybridized orbitals. Equal in what? In energy. Because if the equal energy, they could form a sigma bond. Okay? There is a difference. The covalent bond, if it's a single, we name it sigma bond. If it's a double, the one down is called the sigma and the one up is called the bi. And you don't have to explain the sigma and bi bond in this sections. We will explain it in the upcoming courses. From where? Yeah. Okay, let's see that first and then get back to your questions, Yanis. First, the subscripted 3 on the p orbital indicate that there are 3 p orbitals. So how many orbital of b? 3 plus 1 s orbital. So the total, how many hybridized orbital? 4 orbitals. The answer from where we get the 4? It's very simple. 1s plus 3p that gives us 4. If it's from type Yanis, sp2. So how many hybridized orbital? What mean of sp2? 1s orbital with 2p. So in total, 3 sp2 orbitals. Ya Hazim. The subscripted 3, and then the s is lifted out like an chemical formula. Here, the 4 sp3 hybrid orbitals in the sp3 hybridized methane molecules are equivalent. They all have the same energy, which is greater than that of the 2s and lower and less than that 2p orbital. As I said, it's hybrid, right? A mix of the characteristics of s and the orbital, even in their energy. Higher energy than s, lower energy than lb. But all of them are equal in energy. That's why they are all of them capable to form with a bond. Hybrid orbitals are orbital of equals, energy produced by the combinations of 2 or more orbitals on what? In the same atom. In the same atoms. Hybridization explains the bond and the geometry of many molecules, as we see here. If the type of sp, so how many hybridized orbital form? 2. Capable to form how many bond? 2. To form which type of geometry compound? Linear. If it's sp3, sp2, this is mean 1s with 2b to form a 3 orbital from type sp2 to 4 trigonal planar, like what we take pH3, pF3, right? Trigonal planar with an angle of what? 120. And the final one that we take, the example of methane that we take, is with 3p orbital to form an hybridized sp3 for 4 orbital equal in energy from a type tetrahedral, and the angle is less than 109.5.